All right, let's not mess up the first couple. You hear me? So you got 1 divided by 0, 1 divided by 0. Then you got 2 to the 0. X to the 0. X divided by 0. Those are all concepts that have to deal with this idea, this test. Notice I'm not asking you to graph the weird graph. I'm asking you to analyze it. So what's the first vertical asymptote? What's the next vertical asymptote? X equals 3. So I got x equals -2, x equals 3. Now what's the equation of the horizontal asymptote? What's the oblique asymptote? You can't have them. You can't have them both. So Ariana, how do you feel? Not that bad so far, right? What's the first vertical asymptote? What's the first vertical asymptote? I'm going to go with the left one, x equals -1. But I'm not going to grade you on the order, it doesn't matter. And what's the other vertical asymptote? What's the horizontal asymptote? There is none. Can't have a horizontal because I have the oblique. Now I don't know how we're going to do this. Notice I b begin at 1, so the b is 1. And the slope, I go up 1 over 2. I go up 1 over 2, so the slope is 1/2 x plus 1. Y equals 1/2 x plus 1. Don't have to graph it. Don't have to graph it. I just want to analyze it. What's the vertical asymptote? If you set that bottom equal to 0, it ain't going to be -3. It's going to be x equals 3 is what gives me the vertical asymptote. How about the horizontal asymptote? What's the degree of the top? What's the degree of the bottom? When they're the same, you're going to divide that by the leading coefficient in front of the x on the bottom. So that's going to be 5 over 1. So the horizontal is going to be y equals just 5. What's the oblique? Again, we're analyzing. That's to the second. I don't know if you can see it. So what's the degree of the top? What's the degree of the bottom? All right. Oh, sorry. What's the vertical asymptotes, Nicole? What's the vertical asymptotes? X equals -2. If you don't see it, you've got to factor the bottom to get that. So it's going to be x plus 2 and x minus 2 on the bottom. What's the horizontal asymptote? If the degree of the top is smaller than the degree of the bottom. Y equals 0. What's the oblique? There is none. All right, this is the side we all fear. Yeah, I know. All right. 0, 0. It's opposite same. Over here, what's the opposite?
-2.
What's the same?
-1.
What's the opposite? Oh, 2, +1. It's opposite same. It's opposite same. Now that spot there, 0, 0, is where my asymptotes are going to intersect. So that's going to give me a vertical asymptote and a horizontal asymptote. And this number 1 up on top is called the Knie. And what's the Knie equal in this case? 1. You ready? From 0, 0, I go right 1 up 1, I pop a dot. From 0, 0, I go left 1 down 1, and I pop a dot. Instead of doing the table, it's sort of like 1, 3, 5 with x squared. There you go. Go -2, -1, pop a dot. Vertical asymptote at x equals -2. Horizontal asymptote at y equals -1. Now I know you might be saying to yourself, well, the degree of the top, degree of the bottom, the degree of the top is 1. I mean, the degree of the top is 0. The degree of the top bottom is 1. Wouldn't that be y equals 0? That's true. But doesn't this shift it down 1? It takes it and moves that down 1 after the fact. What's the Knie? What's the Knie equal? Knie equals 1. So what that means, I'm going to go up 1, right 1 from this center of the axes intersection, up 1, right 1, down 1, left 1, and I'm going to graph it. Where the two axes intersect at 2, 1. So I go right 2, I go up 1, top a dot. That's going to give me a vertical asymptote and a horizontal asymptote. What's the Knie? That means from that intersection, I go up 1, right 1, down 1, left 1. And notice the Knie is the number on top. The Knie is the number on top. Opposite same, opposite same. What's the opposite? What's the same? 0. So I go right 1, up 0, pop a dot. That's going to be my intersection of asymptotes. So the vertical asymptote at x equals 1, the horizontal asymptote at y equals 0. My Knie is 1. So I go up 1 over 1, I go down 1 over 1. Opposite same. What goes on the what's huh? 0. Same. 1. It's basically an x plus 0 on the bottom and a plus 1 outside. So the opposite is going to be 0, 1. 0, 1 goes up. Vertical asymptote at x equals 0. Horizontal asymptote at y equals 1. Notice the Knie is 1. So I go up 1 over 1. I go down 1 over 1. If you look at it closely, technically you can rewrite it instead of x over 2 as 1/2 x plus 1. And then you can write y equals mx plus b at mx plus b. I begin at 1, and my slope is up 1 over 2. All right, let's take a look at it. Where are my verticals? Where are my verticals? Anybody see where the verticals are? If you factor it, it's going to be x plus 3, x minus 3. So there's going to be one at negative 3 and positive 3. Then what's the degree of the top? What's the degree of the top? It's smaller than the bottom, so what's the horizontal going to be? 0. Now, 15, 16, and 17 are all going to have the same general shape. So number 15 is the only one that I think you need to run the table on. So you're going to go to mode 7, you're going to go to mode 7, and you're going to generate a table. Any ideas where we should begin? Let's start at negative 4, and then I'll step by 1. When you hit mode 7, the f of x shows up. You're going to type in the equation 1 over x squared minus 9. I hit the little fraction bar thingy, put a 1 in the top. Down arrow, put the alpha x. Then I square that. Then I'm going to do minus 9. When you enter that and you get g of x, what do? Hit enter again. I like to start 1 to the left of the first vertical asymptote. In this case, it's going to be negative 4. And then I'm going to end at 1 to the right of the vertical asymptote, which is 4. And then I'm going to step by 1. And that's going to generate my table of values. For negative 4, you should have gotten 0.14. For negative 3, you should have gotten an error. For negative 2, you should have got negative 0.02. I'm sorry, negative 0.2. For negative 1, negative 0.12. For 0, I'm sorry, let's see, negative 1 was negative 0.125. For 0, it was negative 0.11. And then it's going to be symmetric. It's going to be negative 0.125. And then at 2, it's going to be negative 0.2. And then at 3, it's going to give me an error. And at 4, it's going to give me 0.14. And negative 4, I get positive 0.14. Really close. And negative 3, it gives me the vertical asymptote. And negative 2, it's negative 0.2. And negative 1, it's negative 0.125. At 0, it's really close. It's negative 0.1. At 1, it starts to go away from it again. And then at 3, it's the vertical asymptote again. That's why I get the error. And then at 4, it's symmetric. It's 0.14. So just having that 1 point in that zone, it lets me know that the curve is up in the top left. Having these 5 points in this area, you can see how it's going to tend. It's going to tend to negative infinity over here on the left, and it's going to tend to negative infinity over here on the right. Then Nicole, I have this one spot out here, and that's going to give me that look. If you have that first graph, if you table that first graph, you should notice that the next 2 graphs are very similar to it, aren't they? So all I need to do is get my asymptotes. For this one, number 16, the vertical asymptotes are going to be a negative 2 and positive 2. What's the horizontal asymptote? Y equals 0. And now, I don't have to table it. All I have to do is look at this ground over here to the left, and it's going to be very much similar to it. It's going to look like this sad face for Stormtrooper. You okay with it? Over here, when I factor it, it's going to have a vertical asymptote at negative 1. It's going to have a vertical asymptote at 1. The horizontal asymptote, because the degree of the top is smaller than the degree of the bottom, y equals 0. And now, just by looking at the shape of the first 2 graphs, it's going to be almost identical. It's going to have the same trend. But a really narrow parabola inside. For number 18, what's the vertical asymptote? What's the vertical asymptote? Now notice the degree of the top. The degree of the top is the same as the degree of the bottom. So I'm going to take that 2 and divide it by that 1. So it's going to be y equals 2 as the horizontal. Now if you want to be really studious, you can go ahead and mode 7 the whole thing. But all we really need is 1 point. And I like to throw 0 at it. So I'm going to put a 0 here and a 0 here. 2 times 0 plus 4 is going to give me 4. 0 minus 1. So I'm going to have a coordinate at 0, comma, negative 4. Again, if you want to put it in mode 7 and do the whole table of values, feel free. Some of you are getting really good at it and very quick. So 0, negative 4 is my spot. Just knowing that, I can graph the whole thing. I want to be careful, don't graph it with a thick line, see it? Not taking any chances. It's an approximation. degree of the top is the same as the degree of the bottom. So it's going to be 4 divided by 1. So it's going to have a y equals 4 as my horizontal. What's the vertical? Set the bottom equal to 0, you get x equals 1. Again, if you want, you can table the whole equation, but I'm just going to throw a 0 at it. I'm going to put a 0 in the top. That gives me 4 times 0 is 0. 0 plus 2 is 2. 0 on the bottom, and for x, 0 minus 1 is negative 1. So that's going to give me a coordinate of 0, comma, negative 2. 0, negative 2. And just knowing that it's in this section, in this left area, I can graph it. And again, I'm going to be kind of cheesy. I like the number 0. John, I like the number 0 because it's easy to do the arithmetic with. Some people just cover up the x's. If you just cover up the x's, you'll get 2 over negative 1. If you just cover up the x's for the first one, you'll get 4 over negative 1 instead of plugging in 0. Same process, degree of the top is the same as degree of the bottom. So I'm going to do the 2 over the 1. Horizontal asymptote is going to be at y equals 2. Where's the vertical asymptote going to be? X equals negative 1. Now, Jihad, I want to throw 0 in for x. If you just cover up the x's, just hide the x's, aren't you left with negative 4 over 1? So when I throw 0 in, that's going to give me 0, comma, negative 4. So I go to 0, negative 4. Uh-oh, steadios, this one's a little different, isn't it? Notice I can't just go ahead and copy it like I did before. When I plot that 1 point, I got to determine it's on the left side of the asymptote or the right side of the asymptote. When I plot that 1 point this time, it's on the right side of the asymptote, so that means it's going to be increasing over on this side and increasing over on this side. Old school, opposite same. Opposite same, opposite same. Old school, opposite same. What's the opposite? What's the same? I'm going to plot that point. I go right 1, I go down 1, 2, 3, 4. Everybody get on the dance floor. The array of points that are going to follow are 1, 3, 5. So from that vertex, I'm going to go up 1 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3, 4, 5 over 1. Go back down to the vertex. Implement 1, 3, 5. Up 1 over 1, up 3 over 1, up 5 over 1. Connect the dots as best you can. Opposite same, opposite same. What's the opposite? What's the same? So it's negative 4, negative 1. I go left 4, I go down 1, pop my dot. I'm going to implement 1, 3, 5, but this time notice it's a radical. And a radical goes outward. So I go up 1 over 1, place my dot. I go up 1 over 3. Instead of going up, I go over more. Up 1 over 5, connect the dots. Absolute of the value is of the v. Opposite same, opposite same. So I go right 2, I go down 3. The slope is hidden in front of the absolute value symbol. In this case, it's 1 over 1. So from there, I'm going to go up 1 over 1. Up 1 over 1, up 1 over 1. Go back to the vertex, go up 1, left 1. Up 1, left 1, up 1, left 1. Continue the process.